Good afternoon, everyone. Good afternoon, everyone. We are going to present this workshop related with the RICs and xApp development, and we are going to present the 6G-LEADER vision of this project. It's also with me, Cesar Likovic, and myself is Germán Castellanos, and we are going to present why it's important to create xApp development in these projects. So there is a small agenda for today, so we're going to introduce the 6G-LEADER all-around based architecture and what are the stations that we plan to implement in this system. So in order to do that, we're going to describe what is the dRAX and what are the RIC and SMO solutions that we have in Accelleran. We're going to have a very short 5 minutes coffee break, and then we're going to jump to the development and demo, and we're going to finalize with some questions and answers. So we're going to introduce ourselves. So myself is Germán Castellanos. I am a RAN system architect here in Accelleran, and we are trying to create some future private G networks in 6G and 5G projects. We work in several European projects, mostly in RAN orchestration, xApp discovery for energy savings, traffic steering, conflict management, and so on. And we try to shape this infrastructure into AI natives and RIC platforms for 6G performance. And with me is Dr. Ensar. He is the RIC product owner of Accelleran. He's going to talk about all of the RIC characteristics and everything. And then he's the product owner. He's specialized in all of these SDK and the framework for the xApp and rApp development, particularly for either research applications and for industrial applications, and is bringing this bridge between the technology and business and the innovation that we need for the all-run RIC in private 5G. So that's who we are, and we're going to discuss a little bit of the project. So basically, this workshop is in the context of the 6G-LEADER. 6G-LEADER is a SNS Horizon joint undertaking in the 2024. Is a Stream B. It's going to be 36 months, so we have 10 countries joining 18 partners that are going to present in different environments. So we have SMEs, we have universities, research institutions, and the industry, and we try to map everything and bring all of these into the umbrella of the 6G-LEADER. The whole idea of the 6G-LEADER is basically to try to integrate AI, ML, semantic communications, and reconfigurable RF technologies into an open RAN infrastructure and architecture. The basic idea of this is to bring the capabilities of the real-time and non-real and near real-time intelligence into the network management by advancing or enhancing energy efficiency and reduce the AMF exposure. We also work in the conflict mitigation between different applications to have a robust operation and to create 5 proof of concepts that are going to bring and validate these innovations for 6G innovations in real testbeds. Basically, the whole idea is to create an architecture. This architecture is based on our own all-run architecture that basically the RIC is the one that orchestrates everything. They orchestrate the intelligent control. So inside the RIC, basically, we're going to have like the low latency, non-real-time RIC applications that are the rApps that has a high-level policy and long-term optimization objectives. While if we want to go faster, we go to the near real-time RIC xApps applications that has the capability of having AI or machine learning driving decisions with semantic awareness. So we are going to implement and enhance this with semantic awareness. And if we want to go to faster solutions and faster optimizations, we are going to dive into the dApps, that is the ultra-low latency distributed control. So we're going to have under 10 milliseconds for controlling the DU or RU level. So these 3 loops are going to be controlled or managed in the conflict manager that are going to ensure the harmonization between these applications. Particularly in this case, we're going to take into consideration xApps and dRAX to safeguard the quality of service and reliability of the whole implementation. And we need to land all of these concepts into the architecture. So right now, we are developing a 6G-LEADER architecture that is going to extend towards different environments, not only all around, but a little bit more bigger than that. And we are trying to implement this all-around disaggregated framework that is going to be divided in the cloud, in the central cloud, the edge, and the cell side. And we're going to focus basically in the near real-time RIC and the edge cloud computing in order to implement this solution. So we are going to have the run optimization, the machine learning driving semantics that are going to be in different parts of the system as well. So So basically, what we're going to see is that we have different characteristics of show and explain this architecture. So this architecture as well is going to be defined in 3 different control loops. So the typical 2 all-run closed loop, that is the xApps and the rApps. And they're going to bring the semantic awareness via the AI and ML techniques. Now we need to implement and increment the velocity by bringing the real-time run control for these distributed xApps, distributed apps that are going to support a 3rd closed loop, that is the DU and RU in the 10 millisecond time frame. So with this, we are going to validate the conflicts that are going to have between these different applications in the system. We have different options. One is the semantic integration. So the first one is that we're going to enhance the dApps, xApps, and rApps by bringing the semantic awareness that will live in this area of the semantic enhanced xApps by bringing the task requirements and the task descriptors towards the full system. As well, we are going to bring the dApps architecture that are going to live in the CU and DU parts, and these ones are going to have the validation towards the non-real-time and near real-time RIC to optimize and to have these intelligent controllers to be able to provide solutions in the sub-10 millisecond scale. The benefits of this is they're going to have real-time inference. We're going to support low fee architecture or low layer architecture to optimize the network. And finally, we are going to have the conflict manager that in this case, we're going to implement a intelligent conflict manager that is going to have the characteristics of training, monitoring, detecting, and resolving and this continuous cycle in the AI engine to provide solutions to the conflicts that can arise in different environments. These are the 3 main flavors that we're going to present in the all-run architecture, in the 6G-LEADER architecture to provide the concept of the project. But who we are, who is Accelleran, and why we are doing this workshop. So basically, we are a telecommunication infrastructure software company that aims to develop turnkey solutions for 5G private networks. Why we do it and how we use it? We do it by AP first, and that is enabled to integrate with cores or with applications that are basically easy to integrate. Then we have the open from hold interface that is able to bring the informations that we need either from our use or from the environment to the all-run ecosystem. So we have the information and the metrics that we need to implement. And then we have the RIC intelligent controller that Ensar is going to explain. That is basically the software developer kit, easy to specify optimization, automation purposes. And also we are going to have the final, the virtualization 5G RAN solutions in a commercial of the shelves that is easy to implement. So in order to do that, we have this ecosystem of 5G private solution that we're going to have the Accelleran dashboard that is going to provide information for the users. We are going to have the dRAX, that the dRAX is confirmed by the SMO, by the Accelleran RIC, by the Accelleran CU and the DU, and we're going to present this into the either Accelleran software or the co-servers that are going to present this solution, software solution. So here we have the different radios that can be integrated to our system and different 5G cores that can be implemented in our system. So we have different industries that we can foresee and have these solutions. So one is the industry 4.0, offshore communications, the smart city, on the construction environment, and with this, all of them are supported by the RIC. So here the question is, how we're going to implement, or how to implement xApps in the RICs to bring this intelligence to the 5G network. So that's the question that we need to ask ourselves, and Ensar is going to give us a solution and to explain a little bit further. So, Ensar.
Thank you, Herman. Can I start sharing? I'll share from my side then. Perfect. All right. So thank you very much, Herman, for the introduction, right, of the project and let's say here Accelleran on our part. And I'll take over now in let's say giving an introduction first into the RIC, so the Radio Intelligent Controller, about the way that we have built it, what are its main features, what is this whole xApp, rApp SDK that we're talking about, and then we're going to transition that into the live demo where we really dig deep into actually creating xApps live on this workshop, and so we will get into the details on how that can be done. So the first thing over here that I wanted to mention is, well, first, why do we need the RIC in the first place, right? So one of the key kind of things that came up with modern networks, which are which can be used in various scenarios, is what if the network can optimize itself, save money, open up new services, build new services, and using all of that using open standards. Right. So the basic challenge that we're facing is that these modern networks are more and more complex, right? And they need to adhere to a wide range of, let's say, requirements, and that keep changing depending on the use case and the vertical that you're deploying it in. So using just static configurations is not gonna, keep up with the challenges and demands of those kind of environments. So that's why we introduced the RIC, as we call it, the brains, right, in the Open RAN world, that brings this kind of optimization and automation to these kinds of networks. So on this slide, I have a quite big, let's say, high-level overview of. I'm sorry, is this okay? High-level overview of what the RIC is, right? So in essence, in order to support a diverse set of requirements that comes from multiple verticals, we need to enable this real-time intelligent control of our radio access network. Now, in order to do that, we need to create a platform that's, first of all, programmable and extendable, right? Extendable by the means of deploying these xApps and rApps on top of the platform, that can actually then use different kinds of optimization or automation algorithms on top. So if I look at this kind of big blob over here, the RAN itself exposes RAN data into a RAN block over here. We'll see what that means actually in the RIC. But all of this vast amount of data, such as KPMs and so on, that indicate the state and the health of the network, can basically be consumed by these xApps and rApps. And this is where the real magic happens, right? These xApps and rApps are where these automation and optimization algorithms really lie, and they utilize all this data to bring forward some analysis and potentially a feedback loop, so it's kind of decision as to impact the network. To impact the network, we need configuration or commands that are built into the RIC. So the xApps can actually utilize one of these commands or reconfigurations to influence the RAN and basically change the network or adjust it in some way. And use cases such as interference management, admission control, traffic steering. We'll get into that as well. So some of these use cases where we have tackled either ourselves or third parties have tackled indeed. Is things like interference management. We've had xApps deployed that actually play around with transmission power or handovers to mitigate any kind of interference effects. Traffic steering in terms of spreading the load or balancing the traffic across cells to optimize resources. Energy efficiency, things like energy saving, so shutting down parts of the network in order to conserve energy when that is possible, right? When there's not a big demand for traffic. Handover optimization, right? One of the key things that our RIC also exposes is direct control over the handover process, so we can actually fine-tune the handover algorithm completely. We've done things like anomaly detection or predictive maintenance, so not just detecting anomalies, but also bringing some corrective actions directly from the applications so that we can mitigate the effects. Admission controls is another, possibility that we have to dynamically manage not just UE level admission control, but also PDU session admission control, so we can really build up different use cases and scenarios on that in order to create, a vast amount of use cases that we can play with. So this is just kind of from the top of the iceberg, right, of the different possibilities that we can tackle using the RIC and the xApps or rApps that sit on top of the RIC. This is a slide where we show some of the use cases that we here at Accelleran, so ourselves, have tried to, tackle in recent years. So we've done a handover optimization xApp where we have taken control of the full handover process and managed to not just look at signal strength as an indicator of what's the best cell to hand over to, but other things like cell load, movement of the UEs, and etc. And with a small scale, type of experiment, we were able to increase our overall throughput by 15% as compared to the regular A3 handover algorithm that normally resides in these 5G networks. We've done energy saving use cases in multiple projects where our main aim is to try to predict the traffic patterns. And depending on the traffic load and the prediction, we try to estimate whether we can shut down certain cells or bring them up depending on the needs of the network. So we try to balance between the network, performance and the energy efficiency. And so in scenarios where, for example, where we have factories or enterprise offices where for most of the night, right, there is no one there. We can easily detect that there's a low traffic demand and easily switch off the cells. So we were able to achieve almost 46%, of energy saving in one day. We've done examples of automatic neighbor relation detection. Since we have this fine-grained or granular, insight into the network, including measurement reports that come from the UEs, we're able to then map our network based just on those measurement reports and detect which cells are neighbors to each other just by using those reports, right? So this is just a use case that came up based on the vast data that we have. So we were able to determine who's neighbor to who. And this was kind of input to the PCI optimization xApp, which basically looks at who's neighbor to who and tries to optimize the PCI allocation of every cell, right, in order to mitigate any PCI issues such as collisions and confusions. So as you can see, you don't need one xApp that does the whole job, right? In our RIC, xApps or functionalities can be spread across multiple xApps, where you can have xApps that just analyze the data and produce added value, so some new data that can be utilized by other xApps, while some xApps are more the actual algorithms and optimizations that run on top of the RIC. And one final addition that we recently added is energy saving scheduler. Now, it's a very, let's say, from the explanation point of view, it's a very simplistic application where we have basically a scheduler where you can pick your cells and schedule their uptime or downtime during the day, the week, the month, or however you feel like it. Now, even though it's not let's say, a very sophisticated xApp in that matter, it doesn't have some kind of fancy algorithm behind it, right? It just shows the possibilities of the RIC as a platform to use the xApp's framework to create additional functionalities on the RIC. So not just functionalities which are, algorithms and things like that, but also some types of automations or any other use case that might be relevant for your specific network that you're aiming to, let's say, optimize or automate in some fashion. So what does the Accelleran dRAX RIC look like? Just to mention this dRAX name, right? dRAX is our product family name, which includes our end-to-end system. So includes our CUDU, as Herman has explained, right? A part of our RAN portfolio, our RIC and our SMO that then connects to different RUs and cores on each side. So just as to understand the wording here, right? Now, that architecture that we have, so the RIC architecture, right? We have here this, let's say, small illustration, which depicts a functional block diagram of the RIC architecture, and we will dive into it. But just to show, we have a small SMO part included within the RIC, right? And I'll explain why that matters. Part of the SMO is the non-real-time RIC over here. So that's this middle block over here. That's how Open RAN as well defines it. And then we have the near real-time RIC, which is this bottom part over here. To the side of it are the xApps and rApps, which are built using our own SDK, which we will explain in a little bit what that means. In basic, let's say, high-level terms, this is a microservice-oriented architecture. So all of these blocks basically run as containerized software applications running on a Kubernetes cluster. One of the advantages, or let's say differentiating factors of the Accelleran RIC, is that it's built as a single platform for both the non-real-time and the near-real-time RICs. So both of them are together. Oftentimes you see that these two things are disaggregated and even two different platforms altogether. But we decided to go with one platform, and one of the advantages to that is that we have a single, let's say, development experience with our single SDK, which can be used to build both xApps and rApps. xApps and rApps, as you know, the differentiation between them is that xApps run on the near real-time RIC, where the feedback loop should be under 1 second, while anything that needs to run above 1 second in terms of the feedback loop is part of the non-real-time RIC or is considered an rApp. Now, in our specific case, right, these xApps and rApps, because we have a unified platform and unified development, let's say, framework, we can also create these sort of hybrid apps, as we call them, which are applications that utilize interfaces or functionalities from both of the RICs in order to satisfy a certain use case. So we don't try to limit people into, what is the use case. We try to actually give you the whole platform there, and you utilize it as best as possible to solve the challenge you're facing in your own scenario and use case. And of course, since it's a unified platform, the xApp and rApp intercommunication is a given by the platform because it's indeed all running on the same thing. Part of the, let's say, the dRAX, right, is the SMO, as I mentioned. Now, the SMO has two, let's say, parts. One is related to our Accelleran RAM, so the CU and the DU that we have. And this part actually has things like the discovery mechanism, the configuration mechanism, and the orchestration mechanisms. All of those allow you to basically deploy CUs and DUs, configure them, discover them, and etc. Right? And all of that done through these SMO abstractions that we have. Now, on the other flip side of that SMO is RIC-related SMO functionalities. So all these, the same functionalities such as the discovery, configuration, and orchestration are also built into the platform for the xApps and rApps, right? So we take care of how you package your xApps, how you deploy them, how you configure them, how you discover them, etc. So you as an xApp developer don't need to worry about these things, right? These are built into the system and are automatically available. The SMO is, of course, accompanied with a dRAX API, which is a sort of API gateway that allows you to basically expose any of these APIs and utilize them. And, of course, a dashboard, which we will interact with in the session, which is our GUI interface into all of this world. And basically in the background uses the APIs. But just to mention that you have a dashboard for easy-to-use access, and then also APIs if you want to do more of a programmatic approach to the challenge. Of course, all of these APIs are fully documented, which we'll also see. So the documentation of all the APIs present in the system are documented and available as part of the product. Now, the non-real-time RIC aspect, which is this middle part over here, one of the highlights to that is this broker, the non-real-time RIC broker. We've implemented the so-called 3GPP PM or performance metrics streaming collector. So this is the official, let's say, 3GPP standardized streaming collector, which collects non-real-time data from the RAM or, let's say, external, let's say, entities and builds them, aggregates them into the non-real-time RIC. All of this vast data is saved in multiple databases depending on, of course, their, the functionality. So we have a time series database that that stores these KPMs in the time series. We have also a systems database which monitors the system health, so through CPU, RAM, general hardware kind of, metrics. We have an events-based events database which collects events from our RAM, and we can monitor things like, for example, the F1 interface, which is the interface between CU and DU, is down. We get an event that actually tells us that happened. And then we have a logs database, which basically is a centralized logging management of all the components in the RIC, including the xApps and rApps, so that we can basically, track what's going on in the system. So these are all these different functionalities, right, that we have. And we've recently introduced an alerting framework into the non-real-time RIC, which allows us to basically exploit any of the data here or a combination of that data to create alerts or alarms, as they're called in Open RAN, and also notifications to the end user that something is wrong in the system, right? These alarms and alerts can also be utilized by the xApps to react upon them in terms of, let's say, fault management or those kind of use cases as well. Of course, as with any modern product, we have a dashboard, which is basically a Grafana built into the product, so you can visualize any of this data that's available in the databases. But we often also say that you can visualize any type of data that's available in the system, including creating dashboards for your xApps as well. This is always nice when you want to demo or showcase those xApps instead of having terminal windows with text running all around, that you have something more visual to show. So it's built into the system, fully integrated and usable by the developers. Now, the near real-time RIC, I guess here the gemstone, of course, of this part is our E2 broker, as we call it. This is the component that officially talks this E2 interface or E2 protocol to the RAM components. E2 is the interface or protocol that Open RAN has defined of collecting near real-time data from the RAN, but also the opposite direction, so the southbound direction. So it also enables direct dynamic control of the RAN from the RIC or from the xApps, right? We've taken an approach where it's an SDK approach. That means that this E2 broker over here as a component does the heavy lifting for you. So, for example, does the SCTP connection, does the ASN1 encoding and decoding, and basically gives the developers the plain text message or the raw message to basically analyze and do something with it, right? So it's our differentiating factor as well, because a lot of other RICs as well in the industry actually need you to create your own SCTP connections and ASN1 encodings and decodings directly in the xApp, while for us it's the platform that takes care of that. In the latest so the versions of the E2 protocol we have is basically the latest versions that we've implemented. As some of you know, or maybe don't, the E2 protocol in Open RAN is divided into what's called service models, depending on the use case that you're tackling. So, for example, there's a KPM service model, which is used to extract KPMs from the RAN to the RIC. And then you have service models like RC, which stands for radio control, or CCC, which stands for cell configuration. And those are more on the other opposite direction, so trying to reconfigure or dynamically adjust parameters inside of the RAN component. Besides those, which is the main highlight point, right, we have a Y1-like interface, which is the ability to actually expose this data to the outside world as well. We have an A1-like interface, which allows us to inject policies into our near real-time RIC. So, for example, either from our non-real-time RIC internally or even from external entities to give us policies which will direct the xApps on how to behave and how to optimize the network. We have an O1-like interface for data enrichment. This is basically as well an interface that allows us to, if we have an external entity, let's say a sensor, just as an example, or for example, the core, right, that can also be an external entity, we have the ability to enrich the data in the RIC by injecting more of that data inside of the RIC and making it available to xApps and rApps. One of the latest additions to that is our core integration. So we were able to, let's say, contact the core, extract, for example, the IMSI or the SUPI, so the unique identifier of UEs, and give that to the RIC as well. In that manner, in environments where privacy is not, let's say, of great importance, so imagine where your UEs are robots and you really want to know their location, you can actually track those UEs because you have a unique identifier attached to all of those UEs, so you can really track them across the network. To do that, right, all of that kind of information is aggregated into what's called the UENIB and RNIB, and we have a first implementation of this kind of database. So it's a database that actually collects information on the network itself, so the infrastructure, cells, the RAN, and etc., with all different kinds of statuses and identifiers, and then also UE level information, so really UE identifiers and other information that goes alongside with the UEs. Now, this is a database which allows xApps to get an overview of the topology, but also correlate data in order to build a view on, what do I have in the network, how can I interact with it, and so on. As I said, just a quick slide on that RIC core integration, because it was something that was done recently by us. So we have the possibility to talk to one of the open source cores in order to extract those unique identifiers. And that really broadened the use cases that we can tackle, because now we can actually track UEs all the time in the network. So that gives us more flexibility in terms of the scenarios we can tackle. Now, that was the RIC as a platform, right? So as you can see, we've built a lot of functionality already into the platform, such as this non-real-time RIC functionality, all these monitoring tools, all these interfaces that you can interact with. And by itself, it's a platform, right? That's an important distinction that needs to be made. It's the xApps and rApps that you build on top of that platform that make the differentiation, right? It's those xApps and rApps that hold the intelligence, the smarts, that utilize the platform and all of its features and functionalities to actually bring something more to your network, right? Now, one of the key, let's say, objectives of mine as the product owner of the RIC is to make creating those xApps and rApps on the platform as easy as possible. Because, of course, if it's hard, then it's not a very appealing product. And since the main purpose of the product is to create these xApps and rApps, that was the main objective. For that, we have then developed this, what we call the xApp or rApp development framework, right? So this framework lies on basically 3 pillars, I would call them. The first one is xApp or rApp lifecycle management, meaning how you package these things, how you onboard them, how you configure them, how you delete them, how they integrate and register within the RIC, how they connect to all these different interfaces. This is all done by the platform itself. So you as an xApp or our developer don't need to worry about that part of the development of the xApp, which I think alleviates a lot of pre-requirements that you first have to do before even jumping into the use case that you're tackling. The next thing is the SDK. The SDK, as with any platform, right, we've built an SDK that has a lot of abstracted functions which you can call, and they're very high level, so meaning you need to supply as little details as possible in order to utilize the functionalities. Concretely, we're using a Python SDK. So we've built a Python library, which you can import into any Python project and get access to all these abstracted functionalities that can help you in, just as example, how to retrieve data from the system, how to issue a handover command, how to do admission control, all these different kind of things, right, that you can do, but they're abstracted behind these high-level functions. And the final one is the xApp or rApp template. This is basically boilerplate code, or I would say hello world type of examples, where you have a lot of commented out code, and you can just uncomment that, adjust it to your own needs, and it runs, right? So really the goal is to give you as much examples of the functionalities and how these abstracted functions work, so that you don't even need to read the dev guide, let's say, but can really jump into the actual functionality of the system. So we have a bunch of those that can help you get started. Of course, for anyone who wants to learn more or deep dive into the SDK, we also have a full-fledged xApp or rApp dev guide that gives more details into these abstracted functionalities and more explanation on how they work. So the whole objective of building such a developer framework is, in my eyes, I wanted to be able to, let's say, give this platform to a group of, let's say, data scientists who don't necessarily have the knowledge of 5G, mobile networks or anything like that, but know, here's my input, here are some actions or feedback loops I can utilize. Can I build an algorithm in the middle which optimizes for something using these two, the inputs and basically outputs that I have at my disposal? So it's really that's kind of the focus, and so to lower that learning curve as much as possible. Now, besides the SDK, right, I wanted to show that the platform itself gives xApp or rApp developers a lot of features around, sometimes even going far beyond what Open RAN also gives us, to give you as much tooling as possible at your disposal, so that you can make your own use case. Doesn't necessarily mean you will utilize all of them, but they're there depending on the use case that you can activate or not. Just to name a few, we have something that we call the xApp dev environment. This is a sandbox environment that with one click you get a, let's say, working xApp deployed with all the pre-requirements installed, and you just focus on coding your middle part, that algorithm part, right, that you need to focus on. As I said, we have access to the E2 protocol, we have built-in xApp configuration, we have alarm management, logs, events, performance monitoring, these kind of things. We have APIs built into the xApps which are extendable, so you can create your own custom APIs and really go wild with the use case that you want to tackle. And as I mentioned before, you can utilize the Grafana, which is already built into the system, has access to all of this data, and you can create nice dashboards that come along with your xApp in order to utilize it for demos and things like that. One of the key things here that I wanted to just mention is this xApp development environment, because we'll be using that in this workshop in the live xApp development to show you how that works. But basically, using a form on the dashboard that we have, with one click of a button, we're able to deploy what we call the development environments. And basically, in the background, right, we take care of deploying this xApp on top of the Kubernetes and integrating it into the system. installing all the pre-requirements that you need and everything like that in that environment. And then we will be able to basically do an SSH connection to that environment, and we will have everything ready for us, including example code already there. So we'll have a fully functioning, let's say, xApp with the first example that's uncommented being retrieve all the information that you have in the system. And so we will see how that goes in the live demo. So now that we know that, that we have an xApp, let's say, development framework ready for us to use, and in order to build these xApps and rApps, it's important to also understand what are these different data and control hooks that are available to us on the xApps to basically utilize. Now, there's one note that I must say here, right? Here I will be talking about the Accelleran's end-to-end system, which includes the Accelleran CU and DU, right? And I will list the different KPMs and control hooks that we have made available in that end-to-end system. Of course, when the RIC is paired with simulators or other, RAN components, then this list is of course different and is basically dependent on that RAN component or simulator that is available. But all in all, the way that we expose the information is the same, right? So I'll just run through the examples of the data that we have, for example, in the system. And mostly RAN vendors, I mean, they stick to the same ones because these are 5G, 3GPP defined 5G counters, which are, mostly utilized in different use cases. So from our CU, for example, we have a bunch of messages exposed to us, like UE measurements, which gives us, let's say, RSRP, RSRQ, or SINR measurements, not just to serving cells, but also to neighboring cells. So that's really a very good overview that we can get on the network with these kind of measurements. We have, for example, from the CU-UP, so the user plane side, we have different counters such as the throughput that we get, the packet loss, for example, the delay, and etc. So all these different counters which are defined in 3GPP. And also from the CU-CP, so the control plane, we also get counters such as how many RRC connections were established, how many were successful, how many failed. Likewise for the number of handovers, PDU sessions, all these different kind of metrics that you can get your hands on and basically utilize as KPMs in your network. This is just a quick slide, but we'll get to this in the live demo on how do we actually get these. There are ready-to-go abstractions in our SDK, which make it very easy to collect this kind of data. Now, besides those, we also have a bunch of events from our CU. As I mentioned, for example, this F1 setup failure or F1 interface failure. We have a bunch of other ones as well that are exposed from the CU. So these are event-based messages, not like these KPMs, which are periodic. So they arrive almost at a 1-second basis onto our RIC. These are event-based, so only when an event happens do you get this message in. And so we have also a way on how to basically abstractions on how to basically read these messages out on the SDK side. In terms of the RAN control of our CU, there's two that I want to highlight, the handover control and the admission control. Handover control literally means that it's not just about editing the A3 handover algorithm parameters, such as the time to trigger, hysteresis, offset, and etc. It's actually taking full control over the handover process. So the CU hands over the handover decision-making to the RIC or to your xApp, and you're in charge of the handovers completely. That means a couple of things, right? First, it's a network side handover view, because normally the handover request comes from the users, from the UEs, which is then UE side, right? While from the network side, you have a network-wide overview, right, of everything that's happening, so you can really make global optimizations rather than, per UE optimizations. And second of all, you have a vast amount of data that you can utilize in the cell selection process. So you're the one that actually decides which cell is best for which UE, and you don't necessarily have to restrict yourself on the RSRP or RSRQ measurement. You can actually utilize any other measurements, such, for example, we did a cell load estimation, which gives you more insight into your network. On the other hand, we also have the admission control. This allows us to, as I said, do UE admission control, but also PDU session admission control. So you can really get, like, the CU will ask you, hey, I have a new UE that's asking to be admitted on the cell. Do you want to accept it or not? This is very interesting in, kind of congestion avoidance scenarios, interference management, or even prioritization, right? You can then prioritize certain UEs and back off everyone else from the network in order, like, let's say, in emergency scenarios or something like that. Just thinking outside of the box, like the use cases that you can utilize this for. The DU itself as well has its own list of KPMs. Some of them are available directly from our E2 interface, such as the CQI, RSRP, RSRQ, some throughput information, and etc. And we also have O1, let's say, performance metrics available, a vast amount over here. Maybe one of the highlights is this PRB usage, so the usage of the resource blocks on the DU scheduler, which is very interesting in a lot of cases, especially to determine the load of the network and etc. So a vast amount of them available as well. Again, you can, we have abstractions in order to get this data, so we'll go over that a little bit. And then finally, part of the system as well is the configuration aspect. So how can I configure my network, or what are the configuration parameters on the CU or DU side? These are some of the parameters that we have in our network. So, for example, you can see that we have the PLMN, the cell ID, the PCI information. You have here handover, parameters as well. All of these kind of things. So these are for the CUCP. Likewise, we have for the CUUP, and there's also for the DU. All of these kind of parameters are available to be, let's say, changed using the SDK. Again, we have abstractions ready to go, and we have APIs that allow you to actually tap into these concrete configurations of the RAN network, and we can do that from the xApp side as well. So think of it that, these configuration parameters are also normally exposed to the SMO, and you would have some kind of operator who would statically configure them or reconfigure them at some points. But using the RIC, you get access to them on a dynamic way. So you can really manipulate these configuration options in a dynamic way using the RIC and monitor them as well. Of course, a disclaimer, not all of these parameters are, let's say, fully dynamic. I mean, if you want to change the PCI, for example, of a cell, you do have to restart that cell, right? Because the actual configuration of the cell is changing. So you have to take that into account. But for example, changing TX power is dynamic, so you can lower that live during the working of the network. So just some considerations to work on. And of course, it also depends on the RAN vendor or the simulator or whatever, what kind of functionalities are exposed. But from the RIC perspective, you're transparent to that. You as an xApp, you need to just understand, let's say, from the data sheet of what you're working with, what are the, let's say, controls or data that I have available to work with. And with that, we come to the actual demo. Where we will jump live into live xApp, let's say, development. So just looking at the time, wonder if maybe you guys want to take a small coffee break now before we proceed to the actual demo, a live demo, just as I think it's a good maybe opportunity to use that break.
In the meantime as well, you can put your questions, if you have questions so far, in the chat, and we can try to go and answer while we're doing the demonstration if it's needed. So, yeah, I would have probably 5 minutes.
Yes, I would say 5 minutes and be here.
2:55.
Time. Yeah, 2:55. I think we will be good. There are no questions in the chat or in the Q&A feature, so maybe in the meantime. Oops, no. Will the slides will be shared? We have the only question that we have right now. Yes, they will be shared alongside the recording of this presentation on the 6G-LEADER YouTube channel. In the meantime, let's go in then to coffee break and see you in a couple of minutes at 2:55.
Perfect. See you then.
Okay, so the coffee break has ended. Maybe now we can dig into the demo part of the presentation.
Yep. We answer the question now, or
yes.
we have a question.
We have a question, yes,
in the chat. So Nicolas asks, where should the RIC be deployed, and how close to the ORAN infrastructure? So
yeah. No, that's a very good question indeed, because it's important, right, especially if we're talking about a near real-time RIC component, right, that you are close to the edge, close to your RAN components, right, so that the latency that you experience is as low as possible, right? Now, thanks to the infrastructure and how we've developed the RIC, right, it runs on Kubernetes, right, and on a Kubernetes cluster. That gives us an advantage because the Kubernetes cluster can be, distributed among many servers, right? And some of those servers might be closer to your RAM. Some of those servers might be in the cloud, right? We've had, let's say, a deployment where parts of our, let's say, we had a server on AWS, so on the cloud, and we had the server here locally in our lab. What we then did is connect these two servers into one Kubernetes cluster, and we were able to basically, when we were installing the RIC, we were able to position, as you saw, we have that kind of microservice-oriented approach where you have a lot of microservices that make up the RIC. We are able to choose where do these microservices get deployed, either on the cloud node or on the edge node, or for that matter of, if you have more nodes as well. So that gives us an advantage of basically positioning, the components. And so in this particular case, right, what I would do is all my near real-time components, such as the E2 interface and etc., would be running on the edge node closer to my RAN, because that makes the latency as low as possible. But other things which are more the SMO or the non-real-time RIC, or for example, the dashboard itself, the front end, right, of the dashboard, that can run in the cloud. There's no reason for running that on the edge, right? Another maybe aspect to this is xApp placement, right? You also have the possibility to place your xApps and choose on which node in the Kubernetes cluster you're going to place them. Now, this also gives us an advantage, because imagine that you have, let's say, a very resource-intensive xApp, and you really need a lot of resources with it, and you don't want to impact the rest of the functionality in the RIC, right, with that. So what we can then do is, add a new server into our Kubernetes cluster, which can be dedicated just for that xApp, and then we run the xApp solely on that server, and everything else runs on other machines as well. That way, that xApp will get, utilize the full CPU, RAM, and other hardware, resources of that server. So that's one of the, let's say, beauties of this distributed architecture of the RIC, which allows us to play around with displacement and also performance and resource management as well. So I hope that answers the question there.
Thank you, Ansar. And we do have another question here in the Q&A. So it is from Muhammad, and it is, I don't know much relevant in this, but 6G and SASA with specific vendor like Ericsson or Huawei, where Accelleran can bring their part with RIC and microservices, or Accelleran works in the area for Open RAN only with customized core and open interfaces.
Right. No, very, very good. I mean, that's a very relevant question, right? So what Accelleran brings, right? We can either bring the full, as I said, 5G end-to-end, including our RAN, right? Plus the RIC on top of that, right? And we can then connect to multitude of RU vendors, so the radio vendors on one side and core vendors on the other side, because those interfaces are open and standardized, and we can work with anyone who implements the standardized interfaces, right? Now, as you said, what about these other RAN vendors? We do also have deployments where we don't use the Accelleran CUDU, so the Accelleran RAN, but we use our RIC together with third-party RAN components, CUDU, RU, and etc. that make up the 5G network. Now here, right, we're talking about Open RAN RIC, right? So one of the key requirements is to have the Open RAN interfaces in order to be able to talk to the RIC. The main interface between the RAN and the RIC is the E2 interface. This is the interface how the RAN talks to the RIC, right? But besides that, so if these components have E2, normally we work out of the box with them. Sometimes it takes a bit of interop testing that you just need to get out of the way, but mostly it's standardized interface, and that works. We've had a number of, let's say, projects where we've done that. The other approach would be, let's say, with RAN vendors who don't have the open RAN or open interfaces available, but do have some other interfaces available in terms of exposing data or exposing some control hooks. Our RIC is flexible enough to also incorporate those. The difference there would be that our interface components have E2 or this 3GPP PS collector, so all of these are standardized interface. But if there's a non-standardized interface, the way that these collectors are built they're built in a modular fashion. That means we can plug in a new, let's say, pipeline that can connect to a custom interface of a particular vendor and still expose the same data upwards into the RIC, right? From that point on, the data is again available in the system, and the xApps and rApps will utilize it as if it came from any of the official interfaces as well. So that would be indeed where we could position ourselves. As I said, the two positionings, either full end-to-end or RIC standalone that connects with open interfaces or custom ones to other vendors as well.
Thank you.
Perfect, thank you. We do have 2 more questions. I don't know if you guys want to answer to them at the end of the presentation, or do you want right away?
I want to answer. I will answer very quickly one. Probably we can check the other one if the time's allowed. Okay, so we are talking about regarding the semantics xApps and rApp development. So if there are any results out ongoing. So what we have presented here, the dRAX that is presented right now, is a commercial grade solution. So because it's a commercial grade solution, is at TRL level 7. 6.7, so it's very robust to go up to the market right now. So you can have a very high number of users connected, with a very high number of RUs connected, with standardized interfaces and so on, as Ensar has explained. However, the semantic-aware xApp rApp development is still in development. So this is part of the investigation and research that we are going to do in 6G-LEADER. Right now, we are creating several POCs. One specific POC is related with the semantic-aware infrastructure and xApp and rApp development. So this is going to be developing next year. And part of this workshop is the partners that are involved in this POC of semantic-aware communications are having the base to start creating the xApp and rApp semantic-aware development. So this is the baseline. We hope that the next year for this time we can have some results, and this is part of the process that we're doing this. So phase A of the POC development in semantic-aware communications is going to be somehow ready by this time, by summer next year. So let's keep in sync to see if we can have some results next year.
Thank you, Chairman. Maybe now we can pass to Purva's question. Her question is related to the xApp in NTN. How can we configure with E2 interface?
Right. So the E2 interface, right, is quite standardized and has its own, let's say, this RC, CCC, let's say, service models, but it's also extendable to have custom service models depending on let's say, the available hardware and the capabilities that we have. So I would say that for the RIC specifically in the xApps, we're quite transparent as to the E2 protocol. The E2 protocol is just a wrapper around how that message gets, translated. There's some headers and fields and so on that allows the xApp to communicate to the RAN, but the payload actually, so for example, what kind of KPMs are available from the RAN, what kind of control hooks are available from the RAN, that's all related to the RAN vendors and themselves, or simulators or other entities as well. So from the xApp perspective, you really need to understand what is the let's say, available configuration or command hooks that these RAN vendors expose to you, and then from the xApp you can use the E2 protocol in order to basically adjust it or let's say run some kind of command. So I hope that answers the question.
On top of that, we have been working on other projects that we have been trying to or working on integrated the dRAX via E2 interface with non-terrestrial networks. Right now, the plan is to do it through end-to-end simulated networks, and the plan is to have more projects that take into consideration real end-to-end networks. But it's a phase, it's a project. As I mentioned, we have the version of research version that we go in a lower tier levels, and this industrial grade solution that is with a higher tier level. So I hope that this solved the questions.
I think so. Thank you. Maybe then we can proceed.
Perfect. All right. So my screen is available. Yes, it's still visible. Perfect. Now we jump into the live demo, let's say, on how we actually develop xApps and rApps on top of this platform. And we'll go through a number of different, let's say, use cases, such as how do we gather data, how do we do inter-xApp or rApp communication. We'll look at the APIs available and how we can utilize them, and some other, let's say, features of the whole ecosystem, which gives us the possibility to create different use cases and scenarios on top of our RIC and the xApps, right? So first of all, the first thing that you get access to when using the Accelleran RIC product is the dashboard, which looks something like this. It's just a front-end page, right, with access to a lot of different features. And so one of the key features that we're looking for is this RIC management, where you have access to the different xApp, let's say, functionalities, right? So as I said, with developing xApps, one of the key, let's say, features that we have is this xApp development environment. This is an one-click install environment that gets deployed alongside your dRAX. It has a working xApp with all the pre-requirements installed, already hooked into the system, registered, all the connections, the authentications, and etc. are done. And you basically get exposed to a template, a working, xApp that you can then modify and start programming and start basically developing your own use case on. So that's always our first thing to do, to deploy our own development environment from here. So we do that from the dashboard. It's the easiest way that we can do it. You can also do it programmatically through an API, but I think for now we'll just stick to the easy to do. So on the RIC management page or let's say a drop-down menu, you can pick this xApp or rApp orchestration. Now this is a page that in general allows us to deploy, let's say, xApps once they are in production, right? Once we've developed them, but we can also deploy this development environment. The way we do that is here in the deploy method. We just have to choose deploy the xApp development environment. Once you click that, you just have to give this xApp a name. I think I'm up to demo 6, I believe, or something, or maybe 7, just to be sure. Just give it a name, right? There are some other metadata that you can put in here, depending, like your organization, the team, the owner, and etc. But these are just like for naming convention, and so that you can recognize your xApp once it's deployed, right? I won't touch them for now. And one of the important bits is you have to provide an SSH password for your development environment. This is so that later on we can actually access this development environment. We're working towards a feature which will allow you to also upload a SSH key immediately, but let's say that's a little bit down the line in development, let's say, roadmap. So here I'll just pick a password. Just do note we've put a little bit of a validation here. You have to put between 7 and 15 characters and at least one numeric and one special character just to make it a bit more secure.
Can you make a little bigger?
Yes. That's a good point. Yes, let's do this. Okay, that's a bit more readable indeed. So we'll do that. And basically that's it. That's all we have to do. And once we click the submit button, basically what happens is in the background, the development environment is basically being downloaded from our repository. It's being installed on top of our RIC, integrated into the RIC, so all the interfaces and clients will hook into the right places, discover the IPs, ports, and all of these kind of low-level details, which then the developer does not need to have to do, and you get access to a development environment. The way we can access it is if we now go back to our menu and click xApp or rApp overview, we should see indeed our demo 7 xApp over here. You see that it has this small badge, dev. That means that it's a development environment and not a production running xApp. And you can see that its status is currently deployed. You can see that, you know, once an xApp is actually running, it gets a status of running rather than just deployed. But for now, this is not a running xApp, it's just a development environment that's being deployed. So that's step number 1, quite easy, right? Step number 2 is how do we access this environment? As I said, we will use SSH. And the only thing we need to discover is the port to which we have to SSH to. Right. So in order to do that, you select your xApp and you click the small show button under the services. This will give you a list of services that your xApp or xApp dev environment is currently exposing, and one of them is this xApp dev SSH. This is your SSH basically server running within this development environment. As you know, this is a Kubernetes cluster, so you need to look at this node port basically column, which gives you the exposed port to which you can connect to towards this xApp. So this is something that we just need to copy. And then I'll do it in a very simple sense. Let's go to a terminal window over here and do SSH. And then don't forget to do the -p and then give the port. Otherwise, it will try to connect to the usual default port number 22 for SSH, but every xApp has its own port, on this machine, so that you can access it individually. The username is always xApp. And then you just give the IP address of, let's say, the host machine, so the machine that's running the actual RIC. In my case, it's this IP. Here I say yes and enter my SSH password, which I have given in that deployment page. And voila, we are now in this development environment. Let me clear it out and give you an overview. Basically, you have one folder here that's called xApp. If I go into it, I have my, let's say, skeleton of my xApp, or what we call the dev environment, right? There's lots of things going on here. We'll cover them in a bit, but you know, you have ready to go Docker files, which allow you to create Docker images for your xApp. There's a Helm chart as well already defined, which you can use out of the box or modify for your own needs as well. And then, of course, we have this core folder. This is where the main Python files are located and where you will start to do programming. Right. As I said, this environment particularly has already Python installed, our SDK installed, all the other pre-requirements that are necessary installed and configured, right? So all of these things have been configured. There's some configuration available in this config folder as well in terms of what are the URLs and ports to some of the services that the RIC uses. But mostly you don't need to touch anything. You can basically just enter this core folder. And here we have a bunch of files. And if I show you the xApp main, you can see what the, let's say, xApp actually looks like, right? So as I said, this is one of the xApp templates. It's a working xApp. There's some builder, code over here, which we can go into detail, and there's a detailed explanation about this in the dev guide as well. We'll get back to it a little bit later. And if you scroll down, you can see a lot of commented out code. Then this is what I meant, right? These are all functioning examples that you can just uncomment and then use for your own purposes. One of the, we get to this while true loop. This is basically the xApp loop. So this is, where the xApp loops over. And as you can see, we're calling this process data function just as an example. And if I scroll down to that one, it's basically this function over here. You can see that what it's doing is reading messages from our data bus. The technology we use is Kafka. So we're using, we're reading from the Kafka data bus, and we have this abstraction that says receive message, right? So we have this xApp object, which is you'll see, which is running through all of this basically code, but basically it has these abstraction functions such as receive message, which will get the message that we are currently publishing on our data bus, where these all these KPMs are aggregated to. And then this is one of the first examples. We just log whatever we're getting from the network at the moment onto the terminal. Right. So as you can see, already a functioning xApp, right? So the only thing I have to do is if I exit this, I can write Python 3 xApp main, and the xApp will start running. And now in a short while, we'll see it go wild. I'll kill it because it's going insane. But you can see that it's starting to receive a lot of messages that are coming in from the RAN itself. All different kinds of messages, which we've also looked at in one of the slides, right? So as you can see, they are JSON encoded messages, so very easy to use in Python as well, because they get translated into Python dictionaries, so you can really access them very easily and access the fields and values inside of those messages. So as you can see, with just couple of clicks, right? We deploy the xApp dev environment, we SSH into it, and we have a working xApp ready to go without needing to do any pre-requirement or preparation work for us to work with, right? So if I look at this xApp, xApp main Python file, basically all those messages that are coming in are stored in this data variable, and from this point on, do something with that data variable, right? From this point on, you can really be a data scientist that is just looking at the data and analyzing it and creating some kind of algorithm around this data. So that is also one of the first examples that we always show. Very easy to use, very easy to get into the development of the xApp, and one of the first examples is receiving data, which is one of the crucial things that we have to see. Now, before we proceed to the next example of the xApp development, I also want to show you one thing. Of course, right now, right as you can see, I'm in a terminal window, and I am, SSHing into the xApp. I'm working, starting it, editing it, and so on. Some people, of course, like doing it in the terminal, use VI and things like that. Some people prefer to have a complete IDE available to them in order to do programming. So I will show you one of the integrations that we have with, for example, VS Code, a popular IDE, right? That you can utilize to then really gain an IDE-like workflow for developing these xApps, right? So how does that work? We will exit from this SSH connection, right, that we've had, and then I will just do one thing, which is instead of having to paste my SSH password a lot of times, right, what I will do is I will just utilize or copy my SSH key with the SSH copy ID command, so that I can then use my SSH key to SSH into this xApp without needing to enter my password all the time. So we can just do that and enter that password one more time just to make it there. So now, perfect, we don't need to enter the password. We can use the SSH key that I have to access this dev environment. So how do we do it? Well, if I open up my VS Code over here, VS Code, as you know, has a lot of extensions that you can install on top of it. And one of the extensions, so if I go to this extensions, is called Remote SSH. Remote SSH comes directly from Microsoft, and it's quite an interesting one. It basically allows me to use my local instance of VS Code and connect to a remote machine using the SSH protocol. It will install a small server, let's say side code, on that remote machine, and then allow me to basically connect to it and connect my IDE as if I was on that machine. right? So this is very nice when you have a lot of remote machines that you need to connect to, and you can do it all from your, from your own VS Code instance and get access to that machine, not just the file system, but the terminal and other things as well. The beauty of this is, of course, all the other extensions that you have, you can then bring alongside you and work as if, you have everything by your side. So very easy. I mean, I've already installed it. It's already installed on my system. It gets you another tab here that's called Remote Explorer on the left-hand side. If you click that one of the first things here, this is my list of, let's say, SSH, remote SSH machines that I SSH to. But the easiest way you can configure that is if you click the small cogwheel. This will allow you to edit your SSH config file, and this is where you can keep all your SSH details and configurations. Mine is quite long because I've done a lot of these kind of demos, so bear with me. But basically, it consists of a small piece of text like this, which defines the host. You can give it a certain name. The host name is basically the URL, the IP, or however you want to call it. You can then specify the user. You can specify the identity file, which is your SSH key if you're using that, or delete this line if you're going to keep entering the password each time. And then the port, if it's something other than port 22, you also specify that. And in our case, it is because we have a specific port for our xApp, right? So most oftentimes what I do is I just copy this a blob over here, make sure that it's indented right, and then we can say that this is my, I'll just name this demo 7, so the xApp that we've just created. I'll just adjust the here the IP address at which I'm connecting to. Username is always xApp. I just copied my SSH key, so I can use my default one, and I just have to copy that port number, if you remember, which is different for each xApp. So I can just go back here to the dashboard, get my demo xApp, find the dev SSH, and use this node port, which is exposed to external world. I can copy that, and then here we just paste that over here so that we have the port number okay. Once that's defined, right, you have the definition of the remote host. What you can do then is if you click the F1 button, which brings this small command palette of VS Code, you can look for remote SSH. One of the first things is connect to a host. As you can see, you can also have an interactive way of adding a new host, right, which is what I did manually over here, but you can do it interactively as well. So if I click this connect to host, I can now look for my demo 7, I believe it was, and I named it like this. So 2025 demo 7. So if I click this, I get a new window, and you will see here that it's actually SSHing into that remote machine. It is setting up the SSH connection. It's downloading this small server-side, let's say, piece of code, as you can see right now, to that remote SSH, and it's going to install it. And this will be just a hook between my VS Code client and that small server on my remote client. So now, when it's done, you can see here on the bottom left that I'm actually SSH. I'm connected to that remote machine. Now, if I do, click open a folder, as you can see, I'm not anymore on my local computer. I'm actually connected to that remote. And you can see that xApp folder that we were just accessing to the terminal window. So I can pick that folder and open it up here. And I trust myself because I wrote this, so I'll say I trust myself and get it done. So as you can see here in my file editor or folder viewer, I have all those files and folders that we saw in the terminal. And as you remember, in the core folder, we have the xApp main Python file, which is the one that we're seeing. But now you see I'm opening it up in the VS Code editor with all the goodies and plugins of Python and whatever that I have with autocomplete and other functionalities that I can utilize to make my life easier in terms of programming. The beauty of VS Code as well, in one sense, is I can also open up a new terminal window by clicking here at the top, Terminal, New Terminal. And this opens up directly the terminal in that remote machine as well. So from here, I can do cd core, and then again, I can do Python 3 xApp main, and that xApp is started again, right? You can see it's going wild with all the different things coming in. I can kill it with Control-C. I can now start modifying my code and running my xApp again. And in that way, I can have a continuous development cycle where I edit my code, debug it, or anything else that I can think of, right, in terms of the development process. So I think I like this kind of workflow as well. It's a bit easier, it's a bit more visual, gives me all the, let's say, helper tools around. So feel free to choose whatever works best for you. And you can use either the terminal window, other SSH, let's say, clients or opportunities that you have, or use this VS Code, let's say, extension as well. So now that we have this nice development environment set up, right, and we've seen how, with this one example over here, let me just scroll down a little bit. Yep. In this one, we have seen that this example shows us how do we receive data, and we just log it for now in, on the screen. What's happening behind the scenes is that we are, of course, using Kafka, as I said, as our data bus, as the streaming framework. Now, Kafka works as a publish-subscribe mechanism, so you can publish things on certain topics, and then you can subscribe for those topics on other ends and receive that data, right? So that's our main message exchange system that we have in the RIC. One thing that you also have is a little bit up. You have this function called subscribe to topics, and this actually gives you a list of topics that you are subscribed to on Kafka at the moment. These are the default topics that we have available on the RIC for our 5G system. I do notice that we have some legacy 4G topics as well. I mean, I can comment them out as well over here, or tell my team to remove them in one of the next versions of the SDK. But basically, these are some of the default topics that we have on Kafka. Now, I just want to show you one thing. All of these, let's say, topics are also defined. If you go back to the dashboard, you have the documentation and help section, and you can access the xApp dev guide over here via this link. When you get to it, there's a couple of things like, some of the introduction. You have a full SDK overview over here on this tab. So explaining all the different, the library, for example, you have here the xApp library where you can, view all the details on all these different, let's say, abstractions. And you also have this RAN data documentation. Now, this RAN data documentation is based on, of course, the Accelleran CUDU, right, for our end-to-end solution. But this is basically, as you can see, it has the dRAX data bus kind of sections. So if I expand on those, and let's say I'm looking for KPMs right over here, and I click that, and let's say I pick this UE measurements as my KPM that I'm looking for, you can see that all of these measurements have a small description, and then the actual Kafka topic on which you have to listen to get these measurements on. We also provide documentation on how the message looks like in a kind of schema way, so that you can know what to expect if you're listening on this topic, what are the kind of messages to look out for. So this is the documentation aspect of the RIC. So you can basically determine which Kafka topics you need in order to listen for the kind of data, right? Now, as I said, this, let's say, message exchange system is the central message exchange system on our, let's say, dRAX RIC. And it can be also used for inter-xApp or rApp communication, right? So let's now see a different kind of use case where you split your, let's say, functionality that you're looking for into two different xApps, and let's say one xApp is producing some new information that can be utilized by other xApps in the system. So how can these xApps communicate over this interface, right? Well, it's very easy in the sense that we have an example to go with that. The example is, if you scroll up a little bit over here, you see an example saying, how do I periodically publish some new data into the RIC? So what I can just do is I can uncomment this piece of code here. And as you can see, it's very kind of, in Python terms, very easy. Let me try to zoom in a little bit just so that it's a bit more readable. There we go. I just created here a small dummy data, just some kind of, let's say, dictionary. Do note that when we're publishing to the Kafka databus, we're publishing with JSON encoding. So you do have to have a structure which is JSON serializable, right? So a Python dictionary is easy to use. We then define a function that we call periodic publishing, and we define just a while true kind of loop where we use this kind of abstraction in our SDK, the xApp Kafka JSON send message. Now in the send message, we also have to give two different parameters. One is the Kafka topic on which we're publishing, so something like my test topic, and then the actual data that's being published. And here we simulate that we are publishing on a 1 second basis, so we do a sleep of 1 second before publishing the next message over here. And then we use just a threading library in Python to set up a separate thread that's going to be publishing these messages periodically in the background. So nothing fancy, but in terms of Python, right? We have a new thread, it keeps publishing periodic, and uses our SDK abstraction to send that data, right? There's one thing that I'll just do here in the while true loop. Instead of calling this process data, I'll comment that out and just use a time.sleep1 to keep my main thread alive so that the other thread keeps publishing in the background, right? So with that, if I run now my code in the terminal, you can see that it's running, and there's nothing fancy about it. Of course, we're not printing anything to the terminal. So how can we verify that we are actually publishing that data on the databus and is accessible to other xApps as well? Well, the easiest way I can think of is that we actually go back to our dashboard, and let's just deploy another dev environment. Call this demo8. Set a password and submit, right? So just to repeat the process so that we learn it a little bit, but we just deploy another dev environment, and this gives you to show that indeed you can have multiple xApps or the functionality that you're looking for spread into multiple xApps in order to utilize that. I mean, I'll give you the example of that ANR xApp. I mean, at first it was fully integrated into ANR and PCI together, so we were doing ANR analysis and then using the output of that to do PCI. But then we thought about, well, there might be other xApps that need the ANR information as well. So why don't we create a separate xApp that will just publish that to others as well in the system, and be a pre-requirement for a number of other xApps. Just food for thought in terms of the development process and the architecting of xApps. So if we go back, we can see the demo8 is now deployed. And as I said, what we need to do is we need to SSH into it. So let me grab this port. So what do we do? Well, easiest we can do is, of course, let's copy our SSH key. I'll just change the port number now to the new xApp, so that we don't have to keep entering the password. Great. Let's go back here into my SSH configuration. Let's add this new xApp by entering its port. All the other details are exactly the same because it's all running on the same dRAX machine. Just need to indent this correctly. There we go. So, and we just need to change the naming. Of course, this is demo8. Once it's defined, again, click F1 to access the control panel, connect to host, and find my demo8. Here it is. So let's connect to it. bring this down. So let me put this to this side of the window, and let me put this one on the other side. So now the left part of the screen is the demo 7, the one that's publishing things at the moment, and on the right-hand side we have demo 8, which we're just setting up at the moment. So it's installing that small VS Code server on the remote. Just wait a second to complete. There it is. Let's open up the folder here. We will pick the xApp folder so that we get access to all of the files and folders inside. I, again, trust myself as the author of all of this. And then we go to the core and the xApp main, and also I will need to open up my, oh, I cannot see, let me close off this, wait a second, yeah, open up the terminal window as well. Okay. So there we go, and here we will just enter into core. So another example, same example, right? Now, how do we actually get the data from the other xApp that we were just publishing? As you remember, if I scroll here on the left-hand side, we are now publishing to this topic called My Test Topic. So the only difference we have to do in the other xApp is to make sure that we subscribe to this topic as well to receive the data that's being published on it, right? So let's copy the name, and then in this xApp on the right, let's find, here is our Kafka, let's say, topics that we currently subscribe to. Let's just add our new My Test Topic. Let's maybe comment out everything other than that so that we don't get other, let's say, data in our terminal. So we've subscribed to this topic, and basically the rest is the same, right? It will, again, connect to that data bus. It will subscribe to specifically that, and it will log the messages that are coming from that specific topic. So let's run that. I'll just collapse this so it's a little bit bigger. Python 3, xApp main. And as you can see here, we are starting to receive that dummy data that we've defined over here in the left xApp. We're starting to receive it on a 1 second basis from in the second xApp, right? So just to show you that you have the possibility of playing around with this data bus, of exchanging information and utilizing it to your own use case. Okay, so that was the second example we wanted to go through. I will stop this one and exit from it. We will need the second xApp for next tasks. I will kill this xApp as well, stop it as well, perfect. And now let's go into an example where we will look at the configuration API of our RAN. And one of the, let's say, we'll just trigger one of the easy to use, let's say, configuration options, which is to turn off or turn on a cell in the network, just as an example of what can be changed in the configuration, right? So how do we do that? Well, first of all, I want to mention that all of the APIs that you want to, let's say, that you can access from the xApp and that you can utilize in your xApp are also fully documented. The documentation is available here under the documentation and help section, and then this first dRAX API documentation, right? Now, in this documentation, this is actually a live Swagger page, so you can actually test out all of these API endpoints as well directly on this page. We'll get back to that in one of the next, let's say, examples. But one of the things that we want to tackle here is the whole configuration aspect of the RAN. If we scroll down, one of the, let's say, interesting endpoints that we have is this discovery of 5G components endpoints. And one of the interesting ones is also this DUR use. So this is really on a cell level basis, right? So this /discovery/RAN/DUR use is actually the endpoint that we would like to hit and do a get on so that we can get an overview of all of the, let's say, cells that are available in our network. Now, how do we do that from the xApp, right? Well, let's go back to our xApp. We will comment out this code for periodic publishing as we will not need it anymore. And let me scroll down. There is an example on how we can access our API. I believe it's example 6, yes. So it's this example over here. I will copy this code, and then just let me put it. Here we have the while true loop. I won't loop over it, not to call the get method all the time. I'll just put it right before this while true loop, this piece of code, indent it properly and comment it out. So this is just a snapshot code of you define an endpoint, which in our case is, if I go back here, it's this discovery ran dir use. Now, you can also click this small copy button here that you have directly from this page, which allows you to easily copy this and just paste into this section over here. Right. Then we have this actions.create API URL. This is part of the SDK. It actually transforms this into the full URL, including the IP port and other authentication methods that are needed in order to actually reach this endpoint. So you don't have to worry about that. You just literally have to just know which endpoint you're targeting. And then simply in, let's say in Python, we use this requests package, which is, HTTP package, and we do a get on this API URL that was formed. And this is just a simple check, an if-else statement that if we get back a JSON, a 200 response, then we print out a JSON. Otherwise, we do a bit of error handling and so on. I'll just do one addition to that because this is a JSON. I'll just do a JSON.dumps and not in capitals. JSON.dumps and over here say .indent equals 2 just to make a little bit of a pretty print on our terminal. And of course JSON. Since this is all Python, don't forget that you need to import things. And by the way, since this is purely Python, you can also here pip install any Python package that you also need in your project and just import it in your project as well. Right. So this is a fully functioning environment that you can take advantage of. Okay. So with that, we're all ready. So we're just going to hit that endpoint, print it out, and then, it will just kind of loop over. So let's see if that works. We will go to the terminal and run our Python xApp main. Oh, and very good. So it says, what does it say? Time is not defined. That's a very good point because we did not import time. So let's import time, and that should solve our issue here. There we go. So if I open up the terminal window, you see that we have a very large, let's say, Python dictionary or JSON type of message. But basically, it holds, let's say, a key, which is like this, the DU name over here, for example, DU7. And it holds information about which DU it is that's actually making up this cell, which RU is making up the cell with some associated metadata, as well as which served cells in terms of slices, PCIs, and etc. Some other information like max EIRP power, so that translates into TX power and so on. So you get a lot of this data available to you from the configuration or overview of the network. And so this is just DU7, right? And there's other ones over here, so DU6 and etc. Of course, you can get an overview of your network as well directly on this dashboard homepage, where we have a bit of a network topology view. So you see here the DU7 is this small cell over here at the bottom. Just to note, you can see that currently there's 2 cells, 0 and 4, which are on air, meaning they're radiating, and the rest of the cells are actually turned off or basically not radiating, not or on air, right? They're just readily deployed. So let's pick this DU7, right? And let's bring it on air. Let's turn it on, and we can do that through this configuration interface. Now, we know that we're targeting this, DU7, but we need another endpoint which will allow us to edit the configuration of that specific cell. We have a bunch of these GNODE configuration endpoints over here, and the one that we're looking for is the one that is associated to DUs and RUs, which is this one over here, right? So if I copy this one and go back to my xApp and stop the xApp, of course. So now we're going to be looking at a different endpoint. And as you can see, this endpoint actually has a variable inside of it, or a parameter that I need to give. The parameter is always that root name that you see from the discovery endpoint. So if I go and scroll up, it's this root key that you see over here that gives you, which DU and which RU it's made of. So in our case, it's DU7, right? So let's copy that, and we will paste it over here. So with that, we will hit the configuration of that specific cell, and the rest will be the same, right? We're again just creating a GET request to get the information. So let me clear out this and run this thing again. So as you can see, now we don't have such a large, let's say, configuration JSON, but a smaller one which is specific only to this cell. And one of the things you see is that its admin state is locked. That also translates into the cell being off air, right? So one easy thing we can do is unlock it and give this, let the cell come on air. Now, how do we do that? Well, it's very easy. Once you have this configuration, you can edit any part of this configuration and basically post it back on the same API endpoint for it to take effect. Let's try to do that now. Let me kill this xApp and put this window down. So how can we do that? Well, basically this API response.json holds that configuration that we are talking about, right? So let me do something like, I'll create another, variable called config and store this response JSON inside of that config. I, of course, need to declare this config over here. We'll make it a dictionary. So we'll store the response JSON that's coming into this config. And once we do that, right, we access config. Because it's a dictionary, right, we just need to access the right key. As you see, the admin state key is a root key, so I can directly access it right in the dictionary. So if I copy this, I can go to config, admin state equals to, and then unlocked. Now that I have this, I can basically copy this whole thing again, put it here. We'll use the same endpoint. It will create the same URL, but the only time here is we will not use the request.get, but we will use the requests.post method on this URL. And of course, you need to supply the payload, which you're posting to this URL now. You just need to make sure that it's JSON encoded, so you do need to do a JSON dumps of this config variable or dictionary so that it gets sent through. Everything else will stay the same, except, of course, this line. We don't need to save the response from the post again, but we'll just post the response as the JSON. So as you can see, what we're doing right now is doing one get on the configuration, changing what needs to be changed, and then posting that configuration back. So let's try to run this. And let's maybe do it in this way, where I can put this to the side and put the dashboard to the side and open up this window so that we can actually see the status of the cells live. So let me clear this, and then let's run the Python app. So you can see that it did a get, and you can see that the post of the DU7 configuration was successful. And also to the left, you can see that DU7 is now actually turned on, because you can see that it's changed its icon into this wavy icons, indicating that it's on air at the moment. So that's basically our, let's say, playing around with the configuration API that we have in the system. Likewise, you can use this same kind of logic to basically tackle any of the other, let's say, let me just get this up and running, any of the other APIs. So we have APIs where you can actually deploy xApps. So from xApps, you can deploy xApps. It can be an interesting use case to utilize. We have RAN provisioning. So if you want to provision new DURUs or new CU components as well. We have APIs related to the configuration of xApps, and then we have a bunch of for the configuration of the set of the G-Node B. So do note that we have been using this DURU endpoint, but there are also endpoints, for example, for the CUUP or the CUCP configuration as well that can be edited. So you can use the same logic in terms of accessing any of these APIs from the xApp. So next thing that I want to show you is the xApp configuration. The xApp configuration is basically another thing that's built into the framework, into the platform, and into the SDK, and can be utilized to, let's say, different various, use cases that you might be tackling. So let's see how that looks like. Each of the xApps, let me just run this xApp actually so that it's running. But each of the xApps, I mean, when you see it on the dashboard, if you go to the RIC management and the xApp overview, you get your, let's say, xApp Demo 7, and you can see that it has this details column. And if you click this small icon, you can get into its, let's say, configuration page. Each xApp also has a small README that you can edit by yourself, which will appear here. And then it has these configuration parameters. These configuration parameters, can be very simple, as in, a form where you can edit the number. But you can also play around with creating these widgets like sliders or drop-down menus and etc. And I'll show you how we can do that as well. But so these are built into the system, and each xApp can customize these configuration parameters on the fly. One of the interesting bits here is that these configuration parameters are runtime configuration parameters, so not a deployment time configuration parameters. This means that from this page, or using APIs, you can actually change these configuration parameters and they take effect immediately in your xApp. So think of it in this way. Oftentimes you have xApps. Let me give you an example of one that I had. Is we had a handover manager xApp that had actually multiple handover algorithms defined or developed within it. And then through a configuration option, we were able to switch between the handover algorithms. So instead of having to, restart your xApp and switching the algorithms, we just put it as a configuration parameter, and then through the dashboard, we can easily on the fly switch it without needing to restart the xApp itself. So this opens up, multiple use cases that you can use it for. How do we edit this, right? Well, if I go back to my xApp over here, and we'll stop it. In the, let's say, in the xApp folder, you do have this, let's say, xApp metadata.json, which is another file in the core folder. And this is basically that holds some information about your xApp, including the configuration parameters. So you see here the name of the xApp. You can put a little bit of a description. There's a field last edited, which holds the last time that an xApp was actually edited in terms of configuration. And then you have these config options, which is basically a list, as you can see, and it's a list of, let's say, dictionary items that describe the configuration options. So you can see here that we have usually the name, the description, what's the default value, right? Those are the kind of three main things that you want to define. And then you have two optional ones, which you can use or not. Basically, our front end is built using React, and there is a library that we have used to visualize these kind of widgets. It's called the UI schema library. And basically, you can define these two schema options. One is the JSON schema option, which defines a little bit, what type of value we're talking about. And you have the UI schema options, which gives you ability to set different visualizations for that. So, we have here just a bunch of examples, like just a simple number in a form without any specific schema options. We have a slider, which you can pick this UI widget called range, and then you just say that the type is a number, but you have a minimum and maximum range that you can do, so then it becomes a slider. And then, for example, here you can set the type to a Boolean, and you set the widget to select, which allows you to have like a drop-down menu of this, right? So How can I add my custom option? Well, copy paste. That's the hint of the day, right? So we try to give as many examples as possible so you don't need to dig around, but you can just copy and paste. So if I just use this example, copy it, paste it, right? So I have this new section over here. And let's name it something else. We'll say my config and describe it as my new config option. Let's put the default to false, just to make it a bit different. And we'll keep it a Boolean, and we will also use the widget of a drop-down menu just for the fun of it. So now that this is defined, right, if I start my xApp again and go back to my the configuration page and just reload it, of course, and expand this configuration options, you can see that now we have a my config and it's set to false by default, right? Let me do one more thing just to illustrate that it's a runtime configuration option. If I kill this, the question is, how do I access this value, this my config, from my main Python code, right? The SDK takes care of integrating all of that, and you have an SDK abstraction to access all the different configuration options. So how do we do that? Let me just comment this out because we don't need it. And scroll a little bit to the top. And one of the commented out lines is how to access configuration options. We are looking for this first one. Let me copy it. And let me actually go down here to our loop over here. And let's do something like logging.info, and we will just log. So it's xapps.settings.getConfig, and here is the name of the config, right? We've named ours my config. So we just use the name, and with that, we should be able to retrieve the configuration parameter and keep printing it in the terminal. So let's see if that works. And indeed, we get a false printed out over here. So let me just do this. Let me run a side-by-side window again, just to see the effects. So as you can see, it's just printing false according to this line. But let's say that we want to now change that. Let's say if I go to my dashboard and click this my config, select yes, and click submit. You can see that the configuration is set, and you can see here that something happens, and indeed we're getting the true printed out over here. So you see that this is a configuration option that you can read live in your code, and it can get changed and updated as you go. So you can really utilize this in various use cases that you need to really control your code. It can be, as I said, for example, those handover algorithms so you can change between them. Or for example, if your code has certain parameters, let's say algorithms have certain parameters, you can all put them all into configuration options and then tweak them live while the xApp is running instead of having to stop the xApp, tweak the parameters and then rerun the xApp algorithm and etc. So it's a nice feature that you can take advantage of. And one final thing that I wanted to show you today is going to be the xApp API. Just before we do that, right, I said that there's this documentation, this README of the xApps. That's also available to you in here. So there is let me just try to find it. There is this, this README MD, so it's a markdown file, and this file actually gets, let's say, showed or loaded into the front end of the GUI. So if I edit this file and say this is my new xApp over here, and if I run my xApp like this, and of course reload this page, you can see that this content gets edited, right? So we give the opportunity to developers to, write something about the xApp, maybe say what if it's producing something on a Kafka topic. You can document here which topic it is, what's the date, what does the data look like, and etc. To just do a bit of documentation around the xApp, right? And it's markdown, so you can utilize any of the markdown kind of encodings in it. Okay, so now that we've seen that functionality, let's now look at the functionality of extending the APIs, right? So the xApps, they have a built-in API server. And at the moment, let's say one of the things that's, let's say, taken care of by the SDK is that it handles the configuration aspect. So all of this that you see behind the scenes is utilizing, of course, APIs. But we've also exposed this API server to the developer so that if you need and have some kind of use case, you can create your own endpoints on your xApp and utilize that for various scenarios or use cases. How do we do that? Well, we go to the xApp main. Let me just comment this out and scroll to the top. And the APIs are basically defined here at the very top in this builder, let's say, method, where we have this REST API. And here you see that we have a list of different API endpoints that are defined. There's some example ones over here, so 3 example API endpoints. I will create a new one. And how do we create a new one? Well, as I said, copy paste. So we copy, we paste, and we have a new endpoint. We often advise to put it behind the /API/something so that you recognize that it's your custom API endpoints that you're creating. Let's do something like API/test. So it will be a new API endpoint that we have. And as you can see, it's calling this REST API. It's a different file here, a different Python file here that we have. So we'll open that one. And you see that it's targeting this request handler. We'll just rename this because we'll be creating a test handler over here. And so we will basically create the function test handler that will actually be the function that's called when this API is called. So what do we need to do? Basically, here we've defined it. The SDK will take care of making sure that this new API is registered and so on. And the only thing is we have to create this callback function to give it some functionality. So we will open this REST API.py, which is where we define them. As you can see, we import the Tornado framework. It's one of the Python frameworks for APIs, and we use that one. It has its own documentation, right, with its own kind of thing. So feel free to explore that one in order to customize this even further. We've tried to put some, very concrete examples on how to utilize it in the basic sense. As you see, it uses this, let's say, structure of classes where you create a class for your handler and it imports this Tornado request handler. It has a initialization function where you initialize some of the, let's say, variables that you use. For us, it's always important this xApp object is always transferred into this handler as well so that you can utilize any of the abstractions that we use. And then they define functions for this class, for example, the get or the post over here. So to define the endpoint method that you're looking for. So let's do a very simple one. Let's just, again, copy paste. So I paste here. I will name it my test handler as we've defined it in the other file as well. This will stay the same. And then here I'll just edit this. So in a bit of a weird way, but okay, it's how this framework works. The self.write function is the actual API response that you get back, right? So here we can put something like, yes, you hit the get endpoint of the test API. Wonderful. And that's it. That's all you have to do. So you define the callback here, and you define the actual endpoint over here. With that, let's run this. So it's running. Well, one thing, oh no, that's okay. So we have it. So how do we actually now hit that endpoint? Well, first we need to know the URL to that xApp. Again, we can consult the xApp page. Put this whole screen. So we're running this demo 7. Again, I click this show services. Now, instead of going to the dev SSH, which we use to SSH into this environment, we're looking for the xApp API. So the xApp API is exposed at this port over here. So let's copy that. And let's very simply, I mean, if we go to a terminal, we can use curl. That's the simplest. I can put in my IP address, double com, and then hit the, let's say, xApp API port number, and then /API/test. That was the API path that we've created. So if I click enter, you can see that indeed we get that response we have just defined. So this is an interesting way of basically, creating your own custom endpoints. You can create post, put, any other type of endpoint as well. One of the, let's say, recent use cases that I've been using it for is we've created like a machine learning type of, let's say, use case where I had xApps who had a machine learning model, and they were inferring near real-time data against that model and getting some output. And on the other side, I had another xApp which was doing the model training. So it was gathering a long time, monitoring of the network, and then does a training of the ML model. Now, once that model is trained, right, I kind of want to send that model to my first xApp in order to, put it in the xApp and start inferring data. So what I did is I created my own custom API on that endpoint with a post function where I can accept a binary file which holds my machine learning model, and then in my Python code I import that model and start inferring directly. So I don't need to stop. I don't need to create a new xApp with a new model. I can use the APIs to exchange machine learning models, for example, right? Just one example. There's a ton other ones that you can think of course, where you can create your own API endpoints for your own needs. And one final thing that I wanted to show you is one of the latest additions that we have as well in our, let's say, RIC, is the concept of these events, right? So here we have this section called alarms and notifications, and we have this notification monitoring, which actually we are translating into event monitoring in our next version of the RIC. But basically, it's another concept. So about these event-based, not these these periodic messages, but event-based messages. Normally, these would come from the RAM, for example, as I said. But you can also, from the xApps, have messages which are basically event messages, right? So and you can visualize them here on the dashboard immediately. So just to show you how that works, if I go back to my xApp and stop this over here, we have basically here is the example code. It's a bit of a bigger one over here, but basically a dRAX notification or dRAX event, because we're renaming it, it really is an event, not a notification. But basically it conforms to the Open RAN VES events. So there's a standardized format for these messages. And so that's why we can have them from the RAN, but also from the xApps we can generate them, right? So there are some fields here. We've put here some fields that you don't need to change. They're hard-coded by us immediately, and others where you can actually change it. So for example, the event name, here I put F1 is down as a kind of event that happened, right? And there's some other, specific fields over here. So you can put a text field, some additional information. You can also have like a data kind of a field with a Python dictionary. So different kind of things that you can input into this message, and it becomes visible to other xApps and also in that, let's say, on the dashboard to the end user. So think of it, this can be utilized, for example, for fault management. So your xApp can be monitoring, let's say, for anomaly detection. And once you detect an anomaly, you can actually create an event that say, hey, anomaly X detected or something like that, right? So once this message is created, we use, again, Kafka to send this message out to a specific topic. And yeah, we just log that the notification is sent. So let me just run this quickly. As you said, see, the notification is sent. And if I go back to the dashboard, you can see that it pops up over here. So you can see that this specific xApp has sent an event with this name, and you can also expand the details where you see the full JSON body of that message, including all this additional information that the message might be holding. So it's an interesting addition, right? These event-based messages, which you can then utilize and visualize as well using this kind of tool on the dashboard. And one final thing, and I promise that's the final thing, is we also have alarm management. Now, the alarm management we have delegated here to, let's say, Grafana, where in Grafana, we have an integrated Grafana tool as well, right? And there's an alerting framework within it. Here you can utilize a Grafana's interface to create new alarms and new alerts. And since this Grafana already comes with all the different data sources that we have in the RIC, so all these different databases that are associated with the RIC, you can basically create alerting rules based on any of that data that's available. So including these events, for example. So if I'm exploring, if I click here on the Explore button, and you see here we have a database which is used for the notifications or for the events. I can also just, if I look at here and filter by event name, you can see that we have that F1 down event. So if I run this query, actually, you can see that we've received one of those events, and that's the actual event that was sent by the xApp. So this is available in a database, and straight from here you can visualize it in a dashboard, but you can also create alerts based on that. And these alerts, then I won't go into the details, but you can configure them to, once an alert is activated, you can send an email, send a Slack message, or any other view of communication to the end user to notify you that something is happening in the network, and based completely on your own custom logic that you want to implement in terms of the alarms. So with that, I would like to stop there with the demo and potentially open up the floor to any questions and a conclusion if we have for today's session.
In fact, we already have here a question that I apologize in advance because it was sent 40 minutes ago, but maybe it's still on time. It's from an anonymous participant asking if we can also add externally the semantic protocols into the near field and non-real field RIC.
I think it means the near time and
real time. Yeah.
Probably.
Yes.
But okay. Let us know is not the case. Answer.
Can we also add externally semantic protocols? Maybe just a question here. What exactly do we mean by semantic protocols?
Yeah, there are a couple of semantic protocols that aggregate the information in a semantic way. But we are investigated a little bit, or myself, I'm investigated a little bit into this topic. So yeah, I need to investigate a little bit further. But yeah, probably it's a question that we need to answer with more details. Probably if you can write us an email, we can investigate a little bit further into this topic and see how we can give a proper answer. Yes.
I think from a kind of general point of view, right, as you see, the RIC is quite modular. It has a Python environment where basically you can install any Python library. So if there is anything that you need to connect to an external world as well, do know that the xApps completely have access to the external world as well. So we've had, let's say, projects where our xApps were doing something on our RIC, but also getting some other information or utilizing some other controls and hooks from external systems, whether databases, whether other platforms, and etc. So that's all possible, right? So just in a general sense to say.
Okay.
Okay, thank you. We do have another question from Johnny Choke. What tools does dRAX include for using different 5G cores? Open 5Gs, SRS-RAN, OAI, etc.
Yeah. So as I mentioned in our, let's say, 5G end-to-end deployments that we are quite agnostic to the core. So the core connects to our RAN components using the N2 and N3 interfaces. And usually there, as long as they're standardized, I mean, we can pretty much use any core that's available to us. Now, in terms of connecting the core to the RIC, right, that interface is not standardized. There isn't anything out there at the moment which is, bringing that closer. What we have done, for example, as I mentioned, we had a core integration with one of the core, let's say, options. And what we did there is for our RIC, we have, let's say, internally standardized how messages from the core look like, and we have a small adapter layer ready to go. So, if you guys use some kind of core, and we have a list of requirements, what's the type of information that we need from the core, if we can get that data somehow, we have a way of injecting it into the core, into the RIC in an Accelleran, let's say, standardized way, and then it becomes available to the xApps. Just to give you an example, right? When we did this integration, when you're this xApp, right? And we've done discovery of the RAN, but let me just show you here that on our API, right, we have an API, as we saw, for discovering the RAN, which is this one over here. But as you see here, we also have a discovery method API for UEs, right? So if you click this one, just here is an example of how the data would look like. You can see that we will have some kind of identifier on the RIC level, and then you have all sorts of UE identifiers on the CU level, on the DU level, AMF to which it's connected, and etc. Right? So this is something that we get out of the RAN independently from the core integration. If we have the core integration, we have another field added here, which is the IMSI or the SUPI, for example, which gives you additionally that link to connect the and correlate the information from the core. So that's the extent that we got to so far. But as I said, it's still kind of a proprietary interface. There is no, let's say, standardized way of connecting the RIC to the core. But that also gives us an advantage that we can pretty much experiment with that and expose any information that's available in the core. Because as I said, all the ingress into the RIC is very flexible. We can create adapter layers to any. It's a core, it's a database, it's anything else out there that can ingest more data into the RIC.
Thank you, Ensar. I don't know if anyone has any questions. The time is now. So feel free to use the Q&A feature or drop them in the chat. Well, I don't think we will have any more questions, but thank you, Ensar and German, for answering them all. I don't know if you want to wrap it up.
For our side, well, we want to thank you all the participants. There was a very fruitful presentation. If you have further questions, you can write the email to info@accelleran.com or to myself, to germancastellanos@accelleran.com, or to Ensar Selikovic at accelleran.com. We are going to publish this presentation. I think they're published right now, or they're in the process of being published in the website of resources. Right now, I don't know why to me it doesn't appear, but for Laura it does appear in the website of Laura is showing where. So you can go to 6GLeader.eu/resources, and you can find the slides are already there in PDF. You can check all the information. They have links to all of our different parts, documentation, everything. And if you want to continue working, please drop us an email, and we can give you more information. And on top of that, we think that we are going to put the video as well there. So the video of this workshop is going to be there, so you can take the documentation slides and check it out and try to go forward with this. And stay tuned, because we are planning to have next year in the first semester probably a Plug Fest. So we are organizing that. So when we're ready, we are going to have more information so people can start doing xApps, working with xApps, and so on. And yeah, so it's going to be some fun time with this. So thank you, Ensar, for this awesome presentation. Thank you for all of the 6G-LEADER team, and to all the participants being here to wait us for these 2 hours and a half. And yeah, thank you everyone for joining this workshop. So
likewise from myself, indeed, thank you everyone for the attention. I hope that was interesting and let's say has something for everyone to take from this workshop. And it's been a pleasure presenting to everyone. And yeah, thank you once again for everything.
Thank you both. Bye-bye.